Okay, welcome back to the last part of section 6.6. This is one of my favorite parts. You probably can't hear it, but in the background, my kids are watching Star Wars, and and there's a line there where Darth Vader's like, now you will see the full power of the Death Star. And I was thinking about that line, and I know it's corny, and for you guys right now, you'll see the true power of logarithms and why we have them, because you'll see that there are exponential equations that we cannot solve because they don't have the same base. And so the only way we're going to solve this is by using the logarithms. So here are the two steps. Same base. Rewrite so that both sides of the equation have the same base. Set exponents equal to each other and solve. That is like the ideal situation, but guess what? This is college algebra. This is not, baby math. This is going to be some really tough stuff. So what happens if we have different bases where we're going to add and subtract to isolate exponential terms, divide to remove coefficients, and change their logarithmic form and solve? So right off the bat, look at this first one. 4 to the x is equal to 32. 32 is a multiple of 4, but it's not a power. It's not a power of 4. So you're not going to be able to rewrite 32 as 4 to some power. So we have to use logarithms. And this is, again, the true power of logarithms. So it doesn't matter which ones we use. You have to either use log, which is common log, or ln, which is natural log. Because these are the two ones you can evaluate on your calculator, and these are the ones that are make the most sense. Now, some of you guys who have the nice calculators could do it another way, and I'll just show you guys that way on the first one just for fun. So 4 to the x is equal to 32. This one I'm feeling a little log here, so I'll do log. So I'm gonna take the log, I guess you could say, of both sides. So log of 4 to the x equals log 32. And log 32, this is a number, right? It's not something we're going to solve. We don't solve for log. This is going to be a number. Now log of 4 will be a number, but we have this exponent here. And remember, when we're changing things, the power of logs is that I could take this exponent and I can move it as a coefficient. So now we have x log 4 equals log 32. And as soon as you wrap your head around the fact that these are numbers like 2 or 3 or 4.5, the easier things will be, because now in order to get x by itself, I just divide both sides by log 4, and I'm going to get x is equal to log 32 over log 4. Now this is the exact answer. But if you want a decimal approximation, which sometimes you're going to want that, it's about 2.5. And what's cool is that you can put this in your calculator, raise 4 to the 2.5 power, and you get about 32. I mean, it's going to be pretty close. It's not going to be perfect. So let's just kind of check it out myself here. 4 to the 2.5 power. Oh, it's 32 exactly, actually. So it's good. Now, some of you guys who have those nicer graphing calculators, you could do this. Rewrite this in log form. So that would be log base 4 of 32 is equal to x. And then you could just actually put this in your calculator and get the answer. That's nice if you have that. A lot of you guys do have that, but some of you guys don't have that, so you're going to have to do this. Okay? So let's check out B. B is one of those that kind of works out nice because 9 over 27, hopefully you get an inkling like, oh, I think there is some kind of relationship there with 3. So I could rewrite this as 3 to the 2x minus 1 equals 1/3. 3 to the 2x minus 1 is equal to 3 to the negative first power. Okay, hopefully we're good with that. And now we have the same base, and exponents have to be equal to each other. So 2x minus 1 is equal to negative 1. 2x is equal to 0. X is equal to 0. All right, now you can check. These are pretty easy to check. So I would check my work here. Since these are exponentials, you don't have to worry about extraneous solutions. All right, let's take a look at letter C here. So we want to isolate that exponential term. Okay, so this is my exponential term. I'm going to divide both sides by 2, and I get 3 to the 4x is equal to You could say 2.5 if you want, or 5/2. It doesn't matter. But you just know that they are not the same base. You cannot write them the same, so we have to use logarithms. So this time around, I'm going to use natural log, okay? And it doesn't matter if you use log or natural log. It honestly does not matter. Okay, so what I'm going to do is use natural log of both sides. So natural log of 4 to the x equals a natural log of 2.5. And then the power of logarithms, you can take this 4x and move it to the front. So now I have 4x natural log of 3 equals natural log of 2.5. And again, this is just an algebra problem of one step. It could be a one-step equation. This is a number, this is a number, this is a number. So all I have to do to get x by itself is divide by 4 and by natural log of 3. So x is equal to the natural log of 2.5 over 4 natural log of 3. So now be careful when you put this in your calculator. There's going to be some of you guys are going to write it just like this. Natural log of 2.5 divided by 4 natural log of 3. What your calculator will read that as is natural log of 2.5 divided by 4 times natural log of 3. So you have to put this in parentheses. And if you do that correctly, you're going to get about 2.21. Okay? But this is the exact answer. This is an approximate. Okay. Now when you have D, you could go any route you like. So, or sorry, when you have D and it's given to you as an E, you're pretty limited. You could do log if you want to, but I don't know why you would. You have something that's already built for E, the natural number. So I'm going to take the natural log of both sides because you can't write 8 as a power of E. So the natural log of E to the x minus 1 is equal to the natural log of 8. But look at this. Natural log of E, we know that they are the E is natural log is base E. So they're going to kind of cancel out, and you're left with x minus 1 is equal to natural log of 8. And all I got to do to get x by itself is add 1 to both sides. X is equal to the natural log of 8 plus 1. This is its own thing. So when you put it in your calculator, you make sure you close the parentheses around the 8. This is the exact, and it's about 3.08.
Daddy.
Okay.
No, on the 5th movie.
All right, so now one exponential equation expression on both sides. Okay, these are a little tougher. So we have two different exponential equations. Take the log of both sides and solve. Okay, choose base 10 or E. That's what we had been doing. Use one or both properties of logarithms. Notice how this has the same base and x is by itself, or this has, again, we're going to bring the x in front. We're going to use that one a lot. I told you guys earlier. Distributive necessary, combine x terms on one side, constants on the other, factor x, divide. So these are very involved long problems, okay, which is, again, doesn't make it hard. It makes it just fun and more challenging. I like that. I like to challenge myself. So 4 and 3, they're not the same, obviously. So I'm going to take the log of both sides. So log of 4 to the x equals log of 3 to the 2x plus 1. Now, I could have done natural log. It honestly doesn't matter. And I want to make sure that you guys are clear on that. It does not matter if you use log or natural log, okay? So I just chose log this time. If you want to choose natural log, you can. The power of logs is I can move these exponents in front. So you have x log 4 equals 2x plus 1 log 3. And now I distribute over here, x log 4 equals 2x log 3 plus log 3. Remember, this is just a number. It's totally fine to have that. Okay, so now I got to get x by itself. So I'm going to bring this over, all the non-x terms on one side, all the x terms on the other side. So I have x log 4 minus 2x log 3 equals log 3. And we have x, we could factor. I'm going to factor x out from both of these. X log 4 minus 2 log 3 is equal to log 3. And again, ultimately, my goal is to get x by itself. So I'm going to divide both sides by log 4 minus 2 log 3, log 4 minus 2 log 3, and I get x is, sorry, not about, is equal to, this is the exact answer. X is equal to log 3 over log 4 minus 2 log 3. And you could keep it like that. Okay, that's a totally good answer. Okay, all right, looking on to B, I have E. When I see that, hopefully, all of a sudden I'm thinking natural log right away. Okay, so I'm going to take the natural log of both sides. So the natural log of e to the negative 4x equals the natural log of pi to the 1 plus 3x. Now, in doing so, notice I have natural log of e, so automatically I get negative 4x is equal to natural log of pi 1 plus 3x. And the true power of logarithms lies right here. I'm going to take this and move it to the front. So negative 4x is equal to 1 plus 3x times the natural log of pi. Believe it or not, natural log of pi is just a number, so don't get freaked out by that. That's fine. It could be 4, it could be 5, it could be anything. It's a natural log of pi. That's a number, so don't get worried about that. So I'm going to distribute that to each of these terms. So negative 4x is equal to natural log of pi plus 3x natural log of pi. And again, my ultimate goal is to get x by itself. Okay, so never forget that. So natural log 3x natural log of pi, I got to move it over. So I get negative 4x minus 3x natural log of pi is equal to the natural log of pi. And x, I'm going to factor that out. X times negative 4 minus 3 natural log of pi is equal to the natural log of pi. And lastly, we're almost done here because I got to get x by itself. So I'm going to divide everything by negative 4 minus 3 natural log of pi. Negative 4 minus 3 natural log of pi. And I get x is equal to natural log of pi over negative 4 minus 3 natural log of pi. Just leave it like that. All right. I guess these are all kind of the same. All right, so we'll just do this one here. All right, so 5 over 2 to the x equals 3 to the 1 minus x. And again, if you want, you can change it to 2.5. It doesn't really matter. So we could take log or natural log. Now this time I used natural log last time, so let's just use log this time. Log of 2.5 to the x equals log of 3 to the 1 minus x. The true power of logarithms. Bring these exponents to the front. X log of 2.5 equals 1 minus x log 3. X log 2.5 equals log 3 minus x log 3. I'm going to get the x terms on the same side, so x log 2.5 plus x log 3 equals log 3. Factor out those x's. X log 2.5 plus log 3 is equal to log 3. And last is to get the x by itself. So I'm going to divide everything by log 2.5 plus log 3. Log 2.5 plus log 3. And I get, finally, x is equal to log 3 over log 2.5 plus log 3. Okay, we'll stop this one here.